Well, sometimes we do have problems that involve an equation, like converting temperatures. And usually the way this works out is there's variables in the equation, and they give you values for all but one, and then you have to solve for the missing one. So here's an example using the volume of a cylinder. Find the radius of an aluminum cylinder that is 2 centimeters long and has a mass of 12.4 grams. For a cylinder, volume equals pi r squared L. Okay. Well, let's pull the numbers out and write them down. 2.00 centimeters, 12.4 grams, and then we've got this volume equals pi r squared L. So the 2.00 centimeters long, is that one of the variables in the equation? Might it be the length of the cylinder? Yeah, that's the length of the cylinder. So the length is 2.00 centimeters. I'm trying to find the radius. So in this equation, I've got volume, radius, and length. I'm finding R. I've been given length. I need the volume. How can I find the volume of this? I have the mass. I need a density. They didn't give me the density. What kind of material is this made of? Aluminum. There's a table in the book that gives densities. We're going to truck back there. And then I'll probably find out that I put it in as an animation. If I didn't, I should. We're almost there. There it is. Aluminum. See it? 2.70 grams per cubic centimeter. .70 grams per cubic centimeter. So I have the mass, and I looked at the density. I can use those to calculate the volume. So I want volume in cubic centimeters. So I'm going to divide by grams, multiply by cubic centimeters. And then I'm going to use this. It's 2.70 grams is equal to 1 cubic centimeter. So 12.4 divided by 2.7 is the volume. All of these guys have 3 significant figures. So this result has 3 sig figs, but I want to write down 2 extra digits so that I don't have rounding errors. Cubic centimeters. That's the volume. This one requires some critical thinking. It's not going to be obvious what you need to do. Okay, so now we've got that equation. Pi is just 3.14159. It's a button on your calculator. R is what we're looking for. We know what L is. We know what V is. So we need to take this equation and solve for R. It's easier to solve equations when there's letters without numbers and units in the way. Volume equals pi r squared L. So brief review of algebra, rearranging equations. I want to get R by itself. So I'm going to move L and pi to the other side of the equation. I can do that by dividing both sides by pi. As long as I do the same thing to both sides, it's still equal. Pi over pi is 1, cancels out. Divide both sides by L. L over L is 1, it cancels out. So now I've got R squared equals the volume divided by pi times the length. I want r. I need to take the square root of r squared to get r. If I take the square root of that, I have to take the square root, that was messy, the square root of this side too. So square root and square cancel out. R equals the square root of the quantity v over pi l. So we solved the equation for the variable we're looking for, and now we put our numbers in here with their units. 4.5925 cubic centimeters divided by pi. You don't want to lose precision by writing out 3.14. Just use the button on your calculator. And L was 2 centimeters. And then we're going to take the square root of the whole thing. What happens with the units here? What's centimeters cubed divided by centimeters? Centimeters squared. And then when I take the square root of centimeters squared, I get centimeters, which is a unit of length, which would be appropriate for a radius. Here I'm dividing by two different numbers, and so students tend to do funky things with that. So if you really want to divide, use parentheses and multiply. I'm sorry, if you really want to multiply those two, use parentheses. What I do is I do the numerator and I divide by each of the things. Okay, so on the 36X Pro, what you're going to do is you're going to do the square root button first, and then 4.5925 divided by, you could do the quantity, and then the pi. Where'd it go? Don't use it very much. I can't find it. There it is. Plain sight. Pi times 2. Close the parentheses. Press equals. So I'm getting, I should have 3 significant figures because this one had 3 sig figs, that one has 3. Pi has a lot more. 0.85493. So that's going to round to 0.855 centimeters. That's the radius of the cylinder. Any questions? We solve problems on this order a lot in this class. And so if these sorts of problems are just like scaring the bejeebers out of you, or you're just like completely baffled, you might not be ready for this class yet. Yeah, see? I forgot that I did that. I could have saved myself all of that. Here's another one. Find the density in grams per cubic centimeter of a metal cube with a mass of 50.3 grams and an edge length of 2.65 centimeters for a cube, volume equals L cubed. Now, you all should have taken and passed a geometry class. I'm not going to assume that you remember volume equations for all of these. But if I give you the equation, you should be able to use it. Okay? So again, let's sort. We've got 50, I guess we're doing this one in red. 50.3 grams, and we've got 2.65 centimeters. And we've got that equation, and we're looking for a density. So many problems are unit conversion problems, dimensional analysis problems, This one needs an equation though, because we're calculating the density. You can't calculate the density without using the equation. So we need the equation. Density is the mass divided by the volume. So we need the mass and we need the volume. Well, they gave us the mass. Mass is 50.3 grams. They didn't give us the volume, but they gave us what we need to calculate the volume. Volume is the length of this cubed, and they told us what the length was. So we need to do a side calculation here. Volume is the length cubed, so 2.65 centimeters cubed. 2.65 cubed. 18.6, 3 sig figs, carry 2 extra digits, centimeters cubed. That's the volume. Now I have the mass and the volume. I can plug them into the equation. 50.3 grams, 18.609 cubic centimeters. Is this going to give me the units that are requested? It is. Now sometimes it might not. Maybe they want kilograms or something. Well, then you'd have to do some unit converting. 50.3 divided by 18.609. 2.7, I'll get brief. 2.7, 3 sig figs, 7029. So that would round to 2.70. The units are grams per cubic centimeter. What's this cube made out of? Aluminum. This is the density we just used in the previous problem.